Hello, everyone. Ever since the introduction of generative AI technologies, it's been a very popular debate about AI replacing humans. And this one particular part of it that I've been following is AI replacing, programmers and developers. And there are mixed views about it. Some companies have already started replacing, or at least claim that they are replacing their developers with AI tools, though we don't know exactly what is the situation there, what kind of engineers are being replaced with AI tools. Others claim, well, AI is a tool for the developers. The developers who will use it are the ones who will survive. So I thought it would be an interesting experiment to see how far AI can go with to generate really good useful code without having or without writing any code at all. I'm doing this experiment with a problem, and it's a real problem that I have taken for this exercise. It's a problem that we've solved for one of my customers as a part of a larger project. Um, and it's basically taking a US zip code. Take any of the US zip codes and find the nearest airports to that zip code, and also find the IATA code for that particular airport. So IATA codes are these three character codes that are assigned to airports. So SFO for San Francisco, LAX for Los Angeles International, and things like that. I'm going to use the ChatGPT o1 model for this exercise. Of course, I could use, I could have used like a GitHub Copilot or something, which is because it's more code focused. But I thought I would use ChatGPT o1, which is a more accessible model. It is a bit more generic in terms of its usage. So I thought it would be nice to test what a generic model like that can generate. And there are two methods we will be using to solve this problem. The first method is obviously just basically start with a simple prompt, and then keep chatting with the model till you get closer to the code that you need. So that's the general, I would say, the very common approach to using generative AI for code generation, or for that matter, any kind of searches or any kind of information that you need. The second one is a more structured approach. So you take a prompt, you structure a prompt, you put in some sections for instructions, constraints, and then keep modifying that same prompt to get better results and get closer to what you need. This is a better and a more preferred approach. This is my favorite approach to solve these kind of problems, because it sort of gives a nice structure to the prompt. It allows you to version the prompt. You can audit to see which prompt generated what code. It's slightly much a better approach to a more structured approach to getting your job done. So let's see. Let's use both the models and see where we get and how far we get without writing any code, and just instructing the LLM to generate code. So switching to my ChatGPT interface here. As you can see, I am using the ChatGPT o1 model here, and this is my first prompt. Basically, I need C# code, which takes a US zip code, finds the nearest airport's ITA code, and then of course I'm also instructing the model to use the Google Maps API. So that's what we'll be using to find the airports. And this I'm being very specific because I don't want it to go and find some fancy API somewhere which I don't have a subscription to. So I just want to make sure that it uses the Google Maps API. So this prompt basically generates it's basically doing some thinking. It has generated some instructions for me, and then generated some code here. So let's switch to my Visual Studio interface to see and inspect this code, see if it runs, see what challenges we have here before we proceed. So switching to my Visual Studio here. So I have basically it has taken two APIs, the geocode API and the place search API from Google Maps. And then has done some very simple things. It has taken an input, but it hasn't done a lot of validation on the input, which is not very, I think it could have. I would definitely need more validation on the input, but okay, that's a small thing to implement. So we'll see. It is taking the latitude and longitude from the zip, so it is calling, if I'm not wrong, basically the geocode URL to get the lat long of the zip code, and then further finding the nearest airport to that lat long, again using the Google API, which is the place search URL API, and then finally finding the IITA codes, which is, of course, it's using a regular expression, and it's assuming that the IITA code is somewhere in the airport name, which we are not sure if it's there, but maybe it is. So we'll see. We'll find out if this works. But before even I run this, obviously it's clear that it's not going to compile because I don't have Newtonsoft on my machine. And this is where I think a little bit of an experienced programmer comes in, because all I'm doing is just getting some JSON responses from APIs, and I'm getting some fields out of that responses. I'm not doing any heavy querying or any kind of complex queries on those JSON objects. So I really don't need a Newtonsoft like framework to do my work. Now, again, this is the limitation of LLM, because it's a generative technology, and it's the data that it has been trained on shows that every time JSON was used in any program that Newtonsoft was the library used, it has blindly placed that library in my code without even thinking about, like, do I really need such a heavy library? So that's one thing I would like to replace. I don't want to use Newtonsoft. I would like to use a simple .NET library for JSON parsing. And the second thing I would like to do is move the API key out of this, move it to a config file, and then I don't want to expose my key here. So let's see if we can instruct the program or instruct the LLM to basically do these two things and see what code it can generate or how it can help us to fix these two things. So going back to my chat interface, to my next prompt, and then it's the prompt saying, hey, generate the code without using the Newtonsoft library, and also use the configuration manager to load the API key from config.json file. So yeah, once again, it has generated some code. So let's go back to the to my Visual Studio and see what code it generates. So I take the next one. So this is the code output for the second prompt, and let's see what changes it has made. And yeah, so it has included system.text.json, which is really nice. That's exactly what I want to use. It has also moved the API key out of this. So now let's see if we run this, what output do we get? Okay, so it's compiled. It's asking me for the zip. I'm going to give a California zip code just as a test. Sorry, 4108. And let's see what it gets. So it's found the lat long, and of course given me a whole long list of output or locations or result here. But of course the first two are airports, but then after that there are all sorts of different heliports, and there are a lot of other businesses, airport related businesses, limousine businesses and things like that, which I don't want. I want just the airport. So that's the first thing I want to do is I want to first of all reduce the output by 3, take only the top 3 result, not everything. Secondly, I want to also then look at making sure that it restricts to airports and not everything else. And then we'll look at IITA code. So one of the other things that you can notice here is that it is not able to find the IITA code in the name of the airport. So we'll see. We'll have to find that information somewhere else. So let's see what we can do for the next couple of prompts. Um, Switching back to my prompt here, and sorry. Yeah, so first prompt I have given is modify the code so that it only picks up the top 3 nearest airports. Let's see what it does there. So again, I will remove my previous program file here and add the new one which has been generated as a result of the new prompt. Okay, and you can see that it has replaced the function to get top 3 nearest airports. Let's also see how it is finding the nearest airport. It's basically okay, so looking at only the first 3 result set. Okay, so okay, so let's see if what we get here. Just I mean, I'm assuming that it will still return the same result, but except the top 3. But let's confirm it. Okay, so strange enough, it is actually not giving any airports at all now. It is only giving some nearby services. So I don't know how it is getting this information. I don't see any distance calculation there. It looks like it has only picked up the top 3, but somehow these 3 results are coming out. I'm assuming it's some distance related thing that the API is sending back, and maybe that's why it's happening. But but let's so we need to definitely instruct it further and be more precise about what we really want. So let's try some other prompts and see if we can get better results or better code. So what I'm going to do now is, okay, so I'm going a bit more elaborate. I'm saying, okay, top 3 results are still not airports. These are airport services. And I'm also giving it examples of what airports should look like. So airports near zip code should be like San Francisco International Airport and San Jose Airport and things like that. And I'm also asking it to go deeper into the JSON output and to find the IITA code, not just in the airport name. Hopefully, I'm hoping that the IITA code is there somewhere in one of those JSON files. Or the entire result itself. So let's see if we can do that. So yeah, it has generated the code here again. So yeah, that's the code here. Let's switch back to our Visual Studio and see what that code does for us. So I'm going to just again add the 4th file. Yeah, so now what it does is let's see. Yeah, so now it is using 3 APIs. It is using the nearby search and also using place details. So it's trying to get the details of the place that it finds and then going deeper into it to see if IITA name can be found. What it has also, let's also look at the the IITA code to see what it is doing exactly. So this is the top 3 airports, and if I go to IITA code, this is code from name and address component, short name. It is trying to basically find everything, and then I think trying to find the IITA code in there. Yeah, so it's basically doing a short name match again on the IITA code letters, and so it's doing a bunch of regular expression matches on various properties to see if it can find the either in the address component or the name component or the place ID component, that it can find something that looks like a IITA code. So let's see how this works. Okay, still no airports and no IITA codes. So I think we'll have to do something better. I don't think this is going to work out. So what I have done is I I did a little bit of research so that I can guide the LLM better. So I went to the Google Maps and did a search for airports near 94108 to see what it finds. And it looks like it finds most of the things. It is finding, though it is finding other businesses, but there most of them are actually airports. What I also realized that it is actually taking the airport near 94108 as a search query. So it's a very different API it's using. Actually, it's not doing a nearby API. It's actually doing a proper search with a query of airports near 94108. So I'm going to instruct my LLM to do this exact thing and not use the other APIs, but use the search API. So let's switch back to our prompt here and see how we can instruct the code to do that. So yeah, so still no significant airports in the result. So I have asked it to say, hey, don't do the nearby search. Instead, use the simple maps search and use a search string like airports near the zip code. So let's see if it understands this, and let's see what it generates out of it. Again, it has generated some code. So let's switch to my Visual Studio here and see what we get. So again, remove this. I am going to shift to the fifth one, and let's see what it has done. Okay, so it has replaced the geocode URL with text search, which is nice. It kind of understood exactly what we want. So we are so here's the let's see what search query it has here. Okay, so it has taken this as the search query, basically airports near zip code, and it is using the search URL to, yeah, there it is, search URL, and it is executing that. So hopefully we get a better result this time, at least get the airports, if not the IITA codes. So let's run this again. Voila. Okay, so at least the 3 airports are here. We get what we need, but still no IITA codes. It has found some random number there, 1701, which I don't know what it is. Okay, so we are halfway through our problem. I guess we have found the airports, but we now need to find the IITA code. So again, I have to do some research. So I took this URL that the API is returning and looked at the output, and clearly the entire output has no IITA code in it. So we're going to have to basically run this, do something else here. We will have to probably find the IITA code somewhere else. So what I did is I did some research, and I found out that on GitHub there is a database of IITA codes. It's a CSV file. So I thought, okay, let me take that and ask, get the raw URL for it, and ask the code to actually use that as an input to find the IITA codes. I could have also attached the file, in which case it actually reads the file, makes it a little simpler. But again, I'm just trying to see. We also, as I said, have to find out the limitations of what LLMs typically do. So going back to my prompt here, and I have, okay, so here's the next prompt. Keep the same code for the nearest airport search. I am just making sure it doesn't disturb anything there, because that's working just fine. But find the IITA code in the CSV file at this location. So that's the location I have. Let me actually take that location and show you what it looks like. So maybe here. Yeah, and that's your code. So this is all the information it has. These are the headings, and these are all the so this is what we need. This code is what we need, and we need the name part of it, which is the airport name. So we have, these are airport names. So let's see how that works. So switching back to my prompt here, or my actually, yeah. Prompt here, it has again generated the code, I believe. Yes, it has generated the code. So let me switch to Visual Studio, take this out. And see what happens here. Okay, so interestingly, a much longer program now. So I don't know what exactly it is doing, but we'll find out. It has taken the search URL and it has removed the other API. It is now replaced. It is now using an airport CSV URL which I had given it, and assuming that it will now read that. And so the reason why it's longer now, the program is longer now, because it also has to read the CSV file. So we have so that's the load airport CSV async. Now here, if I see what it has done is basically, okay, it has taken it, split it comma wise, and it is assuming that the first column is identity, the second column is type and name. Now, this is where it becomes tricky for a code generation or a generative system, because it has no idea what is there in the CSV. It basically says, hey, okay, the data that it has been trained on shows that every time it reads a CSV file, these are the typical 3 columns that it finds in the CSV. So it has assumed that those are the 3 columns that you will need, and then somehow trying to sort of figure out, the IITA code out of it. So clearly this is not going to work, but let's still try and see what it generates. It'll be interesting to find that out. So again, running the code here, using the same zip code, and again it has found the airports, but again, as you can see, it has randomly picked up some city name, I guess, as the IITA code, because I think that's the 3rd entry in the column. So it has no understanding of the CSV file itself. And so we are going to have to do something more than just giving it the CSV file. So let's see what the next prompt would look like if we have to further instruct the code generator. Okay, so first thing I've done is I said, okay, don't use latitude and longitude. So one of the things you find in this is that it is actually trying to search the airports, the ITA code with latitude and longitudes. Yeah, there it is. So it is basically trying to find a distance with the latitude longitude, and trying to search the CSV file to match the latitude longitude in the let me just see. There it is. Yeah, get airports by text search. So yeah, it's taking the lat long and returning the lat long also, I guess. Yeah, result, and it is returning the lat long. And then in the airports, yeah, there it is. It is basically going by the latitude and longitude and trying to find records in the CSV based on the latitude and longitude, which is not the right, I mean, it's not the most reliable thing to do. Latitude longitudes are not super accurate in different databases. So I don't want it to do that. I want it to actually use the name of the airport to actually locate the record in the IITA CSV file. So we will change our prompt, and as you can see, I've asked it to not to use the latitude longitude to search the IITA codes. Instead, use the airport name to locate the airport in the CSV file. So let's see what it does now. So I'm going to remove this. Okay, so now what it does is something interesting. It uses the airport CSV. So it's basically taking the names, and again it is name is at 2, IITA is at 12. Again, some randomly it has figured out that that is how it is. So clearly we'll have to fix this also before we can fix anything else. So let's see if we can create another prompt to see, make sure that it knows what it is reading. Um, so let's see, because without that, going and finding these records in the CSV is not very useful. Okay, so here's what it is. So I'm saying, okay, so the CSV file has the following columns. I'm giving it the columns that it has, and I'm asking it to specifically match the airport from the name column and use the code column value as the IITA code. And so let's see how this works. So hopefully this should get close to at least find the right records for us. So let's look at what it does there. I am going to again remove this, take the new one. Yep. Now, this is now correct. So it is basically reading the CSV file, and it is taking the first column as the code, the second column as the name. And that's exactly what we want it to do, because inside the CSV file, that's the sequence. So hopefully now we get our IITA codes also. So let's run this program and see what happens. Okay, 94108. Okay, slightly better. At least it could find the SFO code, but again, for the others, it could not find, which basically means that while it is trying to match the name, but it's not really exactly matching. And so some research I did on this, and I found out that, for example, San Jose Mineta International Airport in the database is written as Mineta San Jose International Airport. So it's a switching of words that has happened, because of which, same for Oakland. I think Oakland is called San Francisco Bay Oakland International Airport, so it's a longer name. And so I think that's not going to work, and so we'll have to do something better than this. So let's first also see how is it searching for the name in the CSV file. Now, if I go down here, I actually, when I was scrolling up and down, I saw that, yeah, so there it is. It is actually using the Leventhal distance, Levenstein distance to calculate the similarity on the names. And I think that's probably not the right way to do it, because it's not about similarity, it's more about jumbled words. It's basically the words in the name of the airport have been swapped around. So Levenstein distance might not be the best way to find it. Maybe it's, I think I don't know. Maybe it could be simpler than that, is all that I'm saying. I mean, it might still be the good way to find, but we could actually do with a slightly simpler algorithm than doing Levenstein distance. So let's see if we can instruct it to do something like that. What I think what it also does is, let's see if we can find best matches, normalized combined distance. Yeah, I think that is what it is. So let's see if we can get it to match the names better. So let's see if we can create a prompt that might give us a slightly better search algorithm. Okay. So now what I've done is I've become a bit more deliberate on the way to find the airport. So I'm saying split the Google airport name into separate words, make a list of different combinations of these words. Don't remove words, so make sure that you don't remove any, because international or airport are common words. Don't remove anything, just shuffle them around, create all possible combinations, and then find the match. Basically find the, the either a substring a match or the whole match should from the Google airport name to the the database airport name. You can also see I have had 3 revisions of this till I came to this point. I don't want to go through those revisions because they were all again tweaks made to the same prompt. But this is a good prompt that we got, which finally generated some meaningful code. So let's see what this prompt has generated. So switching back to my Visual Studio here, this. Okay. So now, okay, so basically let's see what it has done now. Load configuration, all that stuff is fine. And it is done a permutation matching. So basically it is doing permutations now. It is splitting the name and it is generate all possible permutations of that, and then I'm assuming it is also doing some combinations here. I guess it's swapping words, so I'm assuming that there are some combinations also going on here, though I don't see it. But let's see what it generates anyways, and see if we can get a slightly better result. Okay, yeah, there we are. So it has basically found out all the 3 airports and all the 3 different IITA codes, and they are pretty accurate. So I think we've achieved what we wanted to achieve. So that's good, that's fun. So this is how, if you go by the regular prompt, this is what you can achieve after doing so many iterations and so many different instructions. But what's important to learn here is that at some point, as a developer, somebody has to come in and see what's going on. Is the code being written correctly? Understand what it is generating. Like I could see that the 11th sign distance is probably not working. You need to find a better way to do this. Now the question is, hey, is it worth doing all this tweaking and getting code all the time, or is it maybe use some help from AI, but then dive in and write your own code? That's really up to us to decide. Sometimes it's faster to write code, and so that's basically what my conclusion here is, that yes, you can use AI to generate code, but beyond a point, you have to be, the developers have to get into, at least with their knowledge, to say, hey, this is not the right this code still is not production ready. There are many problems with it. So someone will have to go in and fix that. But let's switch to our second method. Okay, so let's look at the second method of creating the same code. In this method, as I said, it's a more structured approach. So it's a structured prompt. There's a instruction section, there is a separate constraint section, and then you keep modifying these sections till you get the result you need. As you can see, I have already instructed it, for example, not to use third-party libraries and things like that. I'm also asking it to make sure that there are validation checks on inputs. And so, just to make sure that it generates a better code. And I'm able to do this because now I have a structure to my prompt. I can think about, hey, what do I really need? What do I really not need? And things like that. So it's also sort of helps you think better. And this is again a place where an experienced programmer will be able to better generate this prompt. As you can see, I have 17 iterations till I got to the right prompt. But these 17 iterations could be reduced, or could be further reduced if you really think through. The developer has a lot of experience, and then that also helps reduce the number of iterations on the prompt, because they know exactly what they want and what output. They also understand how the output is generated. So just going through some of these, I have added some more constraints here. I think, so I've added the not use the latitude, longitude, so something I forgot doing, and so on. So I'm just going on increasing the constraints, but at some point I also realized that, for example, somewhere around, as you can see, it's more on the prompts on the constraint side. But now you will see that I have started doing the match related, the airport match between the Google name and the CSV name. And I'm trying to say, hey, use something like fuzzy search or some technique like that, but that didn't work. Then I said, okay, let's use similarity or substring search, but that also didn't quite work. So the fifth step kept on increasing. As you can see here, I had to give more and more instructions and started becoming a big paragraph. So after a few of these iterations, somewhere around, I think, the 13th area, maybe later. Okay, here, yeah. So here now I started getting a bit more deliberate on, exactly how I need the matching to be done. So I started giving it very precise steps. And somewhere around, I think, the 17th prompt is when it got perfect in terms of saying, hey, match the whole substring in the name of the file, then treat it as a match and things like that. So making all these changes, I finally got to what I wanted. So let's look at that output by switching to my Visual Studio here. And that's the code it generated. Again, very similar to what I had with the previous sequence of prompts. Top airports from Google, it is basically getting the name code and the IOCA code. And yeah, it's the 0, 1, 2 columns, which are exactly what it is in the CSV file. And from a match airport perspective, again, it is doing permutations. So exactly what it did with the previous code. So let's run this and see if it works. So 94108. Yeah, and there you go. It's basically, again, yeah, so exactly the same airports with the same IATA codes. So looks like it works. For testing, we might want to just give it another airport. Maybe this time let's try a New York airport or a New York zip code. So let's try 1005. And it finds only one, actually, and which is actually, I went online to find out, and apparently this is the only airport close to that zip code between, I think, within the first 30-40 miles. So it's the LaGuardia airport, and that's the LGA is the IATA code. So good, I think. Yeah, so as I said, again, this particular technique definitely works a little bit better because of the instructions. You're a bit more organized, and I purposely sort of gave multiple different prompts here to sort of show you how these things work. But ideally, if you really sit down and design the prompt, take some time to design the prompt, you can actually save a lot of time with the different iterations. And these 17 prompts could have been reduced to just a few prompts. So hope you liked the video, and hope you have learned something from this. As I said, it basically indicates that, or it shows that yes, there is some amount of expertise required to build this, and the expertise really helps in guiding the LLM, making sure that the code that's written is more accurate and more it's the right code, because end of the day it's just generating what's popular that it finds in its network, and so hopefully this is useful. If you have any comments, please leave a message, and hoping to make more such useful videos. Thank you. Thanks for listening. How to do the same thing with the second method. So the second method, as I said, is basically about